So we know that a polynomial is a function. Primarily, we look at the exponents. So you can't have negative exponents. So as you're looking at now, it doesn't matter what the coefficients are. The coefficients can be positive and negative. It's the exponents that define whether or not we have a polynomial function or not. So in other words, if I give you 3x squared minus 5x minus 2, all we're doing and all we're worried about are the exponents. Exponents are all positive, correct? So this one's a polynomial function. This one's okay. If I give you 3 over x squared plus 2x minus 5, are all the exponents positive in this case? Which one's not going to be positive? The x squared, because what this is really saying is 3x to the negative second plus 2x minus 5. So because of this, this one's not a polynomial function. Okay? All right, the degree of the function is simply the highest exponent. It's the highest exponent. After you've ordered your terms from highest exponent to lowest, then you just look at what that value is. If it's the fifth power, then it's a 5. The lead coefficient, it's the coefficient in front of the lead term. So you've got to order these to be able to see this clearly. So for example, on this one, what's the highest exponent? 2. What's my lead coefficient? 3. Okay? Basically, you're trying to determine, is it positive or negative? Because positiveness and negativeness is what we're looking. All of these polynomials will be graphed with tails in the same region. It's where they cross the axis that are going to be different. Okay? All right. So if the degree is 1, we have, so for example, y equals x plus 2. That's an example of what kind of an equation? Y equals x plus 2. If you graph that, it would be a graph of a what? So it's a linear polynomial. Okay. If my degree is 2, y equals x squared. What is that the shape of? So it is called a quadratic. That's right.
There's nothing to do with it.
But we use the quadratic formula, right? So a highest exponent is 2. We've got a quadratic. Degree is 3. 3 dimensions. Cube. Cubic. Okay. Degree is 4. 4 what in a gallon? 4 what? Quarts. Quartic. If you have 5 kids all at once, you have quintuplets. Quintic. So do you need to know these terms? Absolutely. Will I quiz them? Quiz you over these? Absolutely. Athena, you had a hand up. Linear, quadratic, cubic, quartic, quintic. Lots of lights? Sure. QU. Yeah, QUI. I dropped my I. Sorry. Quintic. My bad. My bad. Yes, ma'am.
Will you be tested on anything higher than that?
No. All right, so the behavior of polynomials. All right, so we know that this is x squared. We know that the degree is what? The degree is 2. And I want to know, is your lead coefficient, basically, is it, what is it? It is positive 1. We know how to graph this. And if I just wanted a basic shape, this is a parabola who opens which way? So this is doing this. We're going to do some body graphing today, okay? So this is at -3 is where it crosses the y-axis. It's doing this. So my tails are both up. And in this case, my degree is what? Also 2, and my lead coefficient is -1. And if we were to body graph this, where would my tails be? They'd be going down. So 1, 2, 3. So I'm interested in my tails right now. My tails are the arrows. What are my arrows doing? All right. Now the interesting thing is that a 4th degree behaves just like a 2nd degree in terms of the tails. This one we know will cross at -2. But the tails are going to be here and here because my lead coefficient is positive. Well, and what goes on in the middle we'll talk about as we start finding the zeros. But basically, it's going to cross a few times and then go up, like a W. That's just what it's going to do. It's going to. What is the degree of this problem? 4. How many zeros will you have? 4. What are zeros? Where it crosses the x-axis. 1, 2, 3, 4. Well, it should. I should have had it. How would I have done it? Okay, so let's do this a little bit better so that Catherine's happier. 1, 2. No, I'm teasing with you. So, you know, who knows? I don't know. It might do this, come down, and then go back up. Does that make sense?
Yeah.
So we'll get a more accurate graph, Catherine, when we actually physically find these zeros.
Okay, I still want to make sure like it didn't touch a certain.
I got you. You're good. So this one is going to touch at +2 on the y-axis. Would you agree? But because the lead coefficient is what? Then the tails will both be going down. And so it'll do something like this. 1, 2, up, 3, 4. You can just do the arrows for right now, but we will be doing more accurate graphing. All right. So if I just want to do the tails, what are the tails going to do on this one? Up and up, 1st and 2nd. And here it's going to fall in the what quadrants? 3rd and 4th, because it's negative, right? So if the coefficient is negative, down. So basically, if my lead coefficient is even, right? 4, 2, 6, the tails will either go both up or they'll go both down.
About 6 and 6.
Yep. Is it an even value? Even number? Yeah. Okay. All right. Are we good? All right. So if I had to sketch this one, where would my tails be? What quadrant? Okay, hold on. We haven't done these ones yet. What's different about these ones? What are all of these exponents? These are all odd. These are all odd exponents, with lead coefficients being positive here on this side and negative on this side, right? So we know how to do this first one. It's just a line, isn't it? So if I had to graph this line, whose slope is positive, wouldn't you have it doing this? Isn't that the equation of that line, basically? So, even exponents, tails go both up and both down. Odd exponents with a positive are going to go this way, and if it's negative, it's going to go this way. Always. Stuff's going to go on in the middle. It's going to cross the x-axis in different places, but the tails will always end up in the same quadrants. So, x to the 3rd, it's odd, and it's a positive coefficient. Where are my tails? Positive. 1 and 3. Right? Because we call this quadrant 1, quadrant 2, quadrant 3, quadrant 4. In a little bit. Right now, I'm just worried about the tails. All right? What about number Y? Where are my tails going to be? It's going to be in 2 and 4. Do we see that? Because the lead coefficient is negative and the degree is odd. So the degree is odd and the lead coefficient is negative. Okay? Oh, we'll talk about it. Okay? So here we go. Fifth power. Body graph this. Where are your, what quadrants? Are we here or here? Body graph it. I want to see. Where are we doing this? Are we doing this or this? We're doing this. All right. This one's going to be this. Okay. Okay. Are we good on this? Anybody confused? So, if our exponent is odd, 1, 3, 5, all right, we know that if the coefficient is positive, what quadrant are we in? 1 and 3. And if our coefficient is negative, we're in 2 and 4. Are we good? And if our exponent is even with a positive exponent, where are our tails? 1 and 2. And if it's negative, it's 3 and 4. Did I get everything on this page? Yeah. Okay. So let me ask you something. Would you agree that this is positive infinity? And this is? And on the y-axis, this is? And this is? Okay. So if my tails are here and here, as x goes to positive infinity, so as I go right, where does my y go? Does it go up to positive infinity to get to the tail, or does it go down to negative infinity to get to the tail? So I go to positive infinity, correct? And as x goes to negative infinity, what is my y going to do now? Y is going to go to negative infinity because I got to drop down to get to my, okay? What about if my tail does this? So positive infinity, negative, and negative. As x goes to positive infinity, what's my y go to? Does it go up or down? Up. And as x goes to negative infinity, what's my y doing? As I go left, I go which direction? Up. So I go positive infinity. All right? So if my tails are here, as x goes to positive infinity, y goes to positive infinity. And as x goes to negative infinity, what's my y going to go to? Negative infinity also. Are you following all this? That's sideways 8. Okay, here, as x goes to positive infinity, what does y go to? Negative infinity. Put your little infinity signs on your axis. As x goes to negative infinity, what's my y doing? If I go left, then I got to go, do I go up or down? As I go left, do I go up to get to my tail or down? And up means positive infinity. Okay, what about this one? As x goes to positive infinity, what's y go to? And as x goes to negative infinity, what does y go to? Positive infinity. And here, as x goes to positive infinity, what's y going to? As I go right, then I go down. So that's negative. And as x goes to negative infinity, what's my y going to? Negative infinity. They're going to be asking you this on the homework. But what they're going to do is they'll say, what is f of x doing as x goes to positive infinity? So they're flipping it around, and f of x simply means your y, correct? So just in your head, ask yourself, as x goes to positive, y goes to what? Yeah, they're both going down, so they're both going negatively. Okay, synthetic substitution. They're both, the y's are both negative. But, yeah, as I go right, I go down. As I go left, I go down. Okay, we've never done synthetic substitution. Synthetic substitution takes a look at your coefficients only. Okay? And it says, if a term is missing, insert a 0 for that space. Every exponent has to be accounted for after the first one. So I have a cubic, I have a squared, I have my linear, and I have my nothing. So every term is accounted for, correct? So I don't need to worry about a 0. So we're just going to put these 5, 3, -1, and 7. All I'm doing, you've never done this before, but this is pretty cool. X is 2, that value goes right here. Now, this is a pattern that you just keep following. The first step that you do is pull down that first number. So this 5 just gets pulled down. Now, what is 2 times 5? Put that here and add. What's 3 and 10? Okay, now we do the process again. What is 2 times 13? Put it underneath the -1 and we add and get. What is 2 times 25? And what do? Add it to the 7, get 57. Okay, what is 5 on your calculator times 2 to the third plus 3 times 2 to the second minus 2 plus 7? Get your calculator out and do that. 5 times 8 plus 3 times 4 minus 2 plus 7. All I'm doing is substituting that value in. So when you do synthetic substitution, this is called synthetic substitution. And our answer is our last value. So f of 2 equals 57. Okay, let's try the next one. Is every term accounted for? What terms are missing? The cubic and the quadratic. So the cubic and the quadratic. What do I insert for those places? So, -2, 0, 0, -3, 5. -1 goes on the outside. What's the first thing I do? Bring down the -2. Now what do? Multiply -2 and -1, and what do I get? Put it there. And I add and get 2. Now what do? -1 times 2 is -2. And I add and get Okay, now again, what's negative 1 times 2? Negative 2? And I add. And negative 1 times negative 1 is? And I add and get, what is a g at negative 1? Right. Okay. Someone figured it out.
I want to know why it works. Like,
I don't know. I don't know why. All right, you try the last one. People who love math more than I do. I love teaching it. I don't know why this works though. All right, do this next one. We have one more page that we have to talk about. Go back and listen to the recordings at home if you forget how to do this synthetic substitution. Sure. Did you get it right? Anybody got a question? Sure. Okay. All right, here we go. Sketch the graph of negative 2x to the 23rd minus 5. So it's basically, where are my tails? Who could raise your hand? Where are my tails going to be in this problem? Is it even or an odd? And is it positive coefficient or negative? Alex? It's going to be the second and the fourth because it is odd and it is negative. So let's fill this in. This is what the book is going to say. What is my y doing as x goes negative? So who can tell me? Raise your hand. As my x goes negative, my y is becoming, what is it? Positive. So we go to positive infinity. And as my x goes to positive infinity, my y then is negative infinity. This is how you're going to answer these problems. As x goes to positive, my y drops negatively. Okay, Kathleen, is that a question or a stretch? Okay? Okay, who can tell us? What number, what am I looking at to decide if this is an even or an odd function? Haley? The exponent. The highest exponent. Okay. All right. What is this one going to look like? Raise your hand if you know how to draw this one. Just the tails. Where are my tails going to be? Emily on the floor. So the first and the... And if I had to cross it at the y-axis, it would cross where? At 2, just out of, for argument's sake. Okay. How many times would this graph possibly cross the x-axis? 24 times. It could possibly, okay? So as x goes negatively, what is my y doing? And as x goes positively, what is my y doing? So if you can't sketch the graph, you're not going to get this part right. Does that make sense? So you got to know in your head what these graphs are looking like. So on your homework, let's open up and let's look at the homework. So on page 341, open up your books page to page 341. You can look, ladies, at the problems later on. I just want to say something about how I want you to approach these. questions. So 341. All right, so 3 through 8, whichever ones I've assigned, they're just asking you to tell, is it a polynomial function or not? Okay, if it is not, I want to know why. Give me a reason. They don't ask for a reason, but I want a reason. I don't want just a yes or a no. It also then says, tell me the degree, the type, and the lead coefficient. 9 through 14 is direct substitution. That's your old-fashioned substitution where you plug it in and work it out on your calculator. 15 through 22, that's the synthetic substitution. All right, that's what we just learned today. On 25 through 27, you will need to tell me if the degree is positive or negative, and the lead coefficient, if the degree is even or odd, and the lead coefficient is positive or negative. And on 28 through 36, absolutely, I want you to tell me the tails. Tell me what the tails are. And the same thing on 38 through 43. I want you to sketch on 38 through 43, give me a sketch of what you think it might look like, showing me where it's going to cross the y-axis. Okay? How many times do you think it's going to cross the x-axis? And it's going to cross the y-axis at what value? Okay? Michelle, what's your question now? Just the tails. Yeah, do one of these things where you give me the tails and then you tell me as x goes to infinity, y does this, and as x goes to negative, y does this. Okay? But on the second part, 38 through 43, I want a little bit more specific, just telling me where the graph crosses the y-axis and give me an example of how many times you think the graph is going to cross the x-axis. And just show it on your graph. Yes? Quadratic, quintic, linear. Okay.